Today, in this video, we are going to study about reflection with spherical mirrors. Earlier, in the last video, we studied about plane mirror, and we also studied about the laws of reflection, where angle of incidence is equal to angle of reflection, incident ray, reflected ray, and the normal at the point of incidence, they all lie in the same plane. Now, what are these spherical mirrors? You see that in the case of, let us say, your bike, right? Or car, the rear view mirror, or dentist. You see, there are so many mirrors which are all not plane mirrors. So, they are spherical mirrors, so they are part of a sphere. Now, let us construct a spherical mirror. Okay, let me try to construct a spherical mirror. Fine. Yes, I am keeping a center point here, right? And I am going to draw a sphere. Fine. So the whole sphere I am not drawing, I am taking part of the sphere. When you see very carefully, watch carefully, this is part of the sphere, and I am going to coat this side with lead dioxide, basically. Then it becomes a mirror. Mirrors are basically opaque. Mirrors does not allow light to pass through. What I did here, I kept this as the center, this is center of the sphere, and this is only a curve, so it is called center of curvature. What do you call it? Center of curvature. Now, let me take the middle point of this curve. Fine, and that is called pole of the mirror. Now, I join with a line between pole of the mirror and the center of curvature. Yeah, I give a long line, I draw. Fine, and this line from the pole passes through the center of curvature. And this is the main line, and this line is called principal axis. Okay, now again I write the terms here. C is center of curvature, right? And P is middle point of the mirror, pole. And PC, the line which is going, that is called PA, that is called principal axis, main axis. Fine. What will happen to a ray of light incident? And with a ray of light incident like this will bounce back in the same line, and that is why it is the principal axis. You will find that the ray is striking. You can imagine in another way. For example, I have got a cup, right? Now a shallow one. When I take a ball and drop it, and it will come back like this. Like that, the ray of light is incident at the pole, passing through the center of curvature. It will retrace its path. Now, the distance between the center of curvature and pole is called radius of curvature. What is this called? Radius of curvature. 20 centimeter, 15 centimeter. This is called radius of curvature. R stands for radius of curvature. Remember, a spherical mirror is part of a sphere. It is a part of a sphere. Okay? So, center becomes center of curvature. Radius becomes radius of curvature. And this is the mirror. And this is the where it is reflecting, it is inward. The reflecting surface is inward. The reflecting surface is inward, and that is why it is called concave. Just like a cave, it is called concave mirror. What is it called? Concave. Inside. Reflecting surface is inward. Okay, now we did this much. We learned about the principal axis. Suppose if I take another ray, let us say, if I take another ray parallel to the principal axis, then what will happen? We have to see that. Before that, I would like to dissect the concave mirror into small plane mirror. You can imagine this to be a plane mirror. So okay, so it is bouncing and going back. But here, you look here, the mirror is somewhat like this. Then this is the reflecting surface. Okay, so I know this is the incident ray. Now it has to reflect back. So what will I do? First I will draw a normal at the point of incident. The normal at the point of incident will ultimately pass through the center of curvature. That is nothing but the radius. Fine. And this is the angle of incidence. If this is the angle of incident, I need to know the angle of reflection. Fine. And I need to know the angle of reflection, and let me draw a ray, angular reflection, reflected ray. This is angle of reflection. You see, it is meeting at a point on the principle, it can pass through. Okay, it is meeting at the point, and that point is called focus. What do you call that point? Focus, right? Now F stands for focus. Remember very carefully that it also obeys, even a spherical mirror obeys the laws of reflection. Angle of incident is equal to angle of reflection. Okay, now let us take another ray which is like this, parallel to the principal axis, fine, and striking the mirror. Again imagine there is a plane mirror, fine. Now what will happen? Again you drop a normal. We know the normal will pass through the center of curvature, that's the radius, right? Now this is the angle of incidence. Then we need to calculate angle of reflection, and when we find the angle of reflection, again that also will pass through the same point where all the rays parallel to principal axis will converge at a point, and that point is called focus, right? Now I'm going to do one more last exercise. With that we will complete the understanding of concave, and next in the video we will see a mirror called convex mirror. This is a concave mirror. Learn the concept: center of curvature, radius of curvature, principal axis, pole is the middle point, F is the focus, rays parallel to the principal axis. I can take another ray, it also will pass through the focus. Fine, I will take another ray, that also will pass through the focus. So all the rays coming parallel to the principal axis, the main axis, will all converge at a single point, and that is called focus. And this focus will be real focus. In the next video we will study about convex mirror. Thank you so much.